Recording in progress. Welcome back, everybody. I'm glad to see so many of you returned. You didn't, slash quit on me, leave.
You didn't have actually any students back out, did you?
I did not see any drops, so that's good. Let's take a look at 12.1. I hope you guys watched the videos. In the previous sections, we were doing parameter, doing the lines as parameterized with T. And we're continuing that here with vector valued functions. So how could I sketch the line segment from on this one? It's just 2D, right? If I do, well, maybe I should give you guys 2 minutes to try this one. It's not too challenging. You know what it is about Lawrence that makes me want to troll him? It's the fucking glasses. He came in looking like he thought he was like Maverick or Iceman on Top Gun. And it's just like, no, I kind of got to fuck with him.
I like my glasses.
They're like cop glasses. I like them too.
I have been told that I do look like a cop with these on. So. Of FBI. But at the end of the day, what does that really mean? Does that look like authority or something? Or like, wait, is that like a negative thing?
No, it's the level of it's confidence bordering on arrogance. That's the cop look. Like they know they're in charge, and some of them just take it a little too far. Some of them take it way too far, but some of them just like they know that they like me. I know I can pretty much get away with anything because your grades depend on me being nice. So I can harass you for a little while, and you won't go all cataclysmic on me. Although I do expect some retribution for fucking with Lawrence yesterday. If he doesn't, I'm gonna be disappointed. All right, I hope you guys did this. Let's just see what we're getting. If t equals 0, what does r equal? T equals 0 cancels out the second component, right? And we just have 1 minus 0. We just have I plus j. I plus j is a vector from the origin to there. And if I do t equals 1, the first half of this setup is gone. 1 minus 1 cancels out. I've just got 1 in this. This is I minus j, which is 1 negative 1. We got a vector going from the origin to 1 negative 1. The actual line segment is this. 1, 1 to 1 negative 1. The R traces this path as t goes from 0 to 1. So there's a little more to the line segment than just that. We might want to include the orientation. We're starting on the top point, we're going to the bottom point. So this is a variation of the R equals R naught plus TV. It's reconfigured such that this ends up being the first point, and this ends up being the second point. With this very strict requirement. on that. That makes that P0 and P1. Now let's up our game and sketch this. Go ahead and give this a try. I would recommend trying to do it with the parameter first. Don't try to switch to X, Y, and Z, but we will verify that afterwards. Or we can walk through it together and you guys can tell me what to do. I see people trying. Let me just give you guys some time. So I just made a little table. Let's see. Okay, so I think the easiest way for me to sketch this as it is I'm going to sketch the YZ and then shift by the X component. So -3, -2 would be here. And then I want to go back 3, so it kind of puts it like right there. If I do everything like that. Nope, ignoring that, okay. And then 0, -1 would be here. Hold on. -3, what am I doing? -3, -2 is down. Yeah, scaled there. Okay, that's 1 point. And then 0, -1 is right here. And then we shift that back 3. This is looking funny. What am I doing wrong here?
negative.
No, I'm doing all right. And then 1, 0 would be right here. And we're shifting that back 3. Maybe a little bit more to the right. 0, 1 is here. And we're shifting that back 3. This is looking weird. And negative 3, 2 is here. We shift that back 3. So is it doing something like this? Looks like it's making like a parabola, right?
Yes.
The X component's throwing me a little off. If I looked at it, if I like rotate my view like that, I definitely see the parabola. So is it a parabola? I'm looking at the equation. If I make z equal to t, then y becomes 1 minus z squared, or y equals negative z squared plus 1. So in the zy plane, it is doing that type of parabola downward like that. It's just shifted back 3 from the origin because of the x. One thing I missed and I did not show is we need the orientation. This path right here, assuming my dots are a little better lined off, I was plotting them in this direction. And as a reminder, our R of t is actually just pointing, is a tracer, is like a tracer light. The cat pointer, the cat laser light. So it's the light is shining from the origin. It's shining this point on this parabola that's going from here, going that way. Or if I look at it from overhead, it's going this direction. So I'm going to get rid of those things right there because I have a bad habit of putting arrows on parabolas. And in this class, at least in this lesson, they are going one direction. The way I have configured T. Any questions? So we got this laser pointer, we're tracing out a parabola along the surface. And this is all taking place in the x equals -3 plane, which is into the page. Okay. We got no questions. Let's try writing this one as a vector equation for the line segment from P to Q. So for those of you that might have problems seeing the image, what coordinates are P and Q. This will help you write the equation. P is not in the x-axis, is not in the y-axis, it's just 4 up. So P should be 0, 0, 4. Q is in the x equals 2, y equals 3, 0 plane position. So what approach are you guys taking? Someone help me out here. There's two ways to do this.
Find a vector PQ.
Find the vector. Let's go with that approach. PQ would be 2, 3, 0 minus 0, 0, 4. So PQ is 2, 3, negative 4. The zeros kind of made that a little bit easier, right? What do I do with that?
Use P as initial point and make the parametric conclusion.
So initial
that-
point is 0, 0, 4 and do T times that.
P times 2, 3, negative 4.
So R of T is 2T, 3T, and 4 minus 4T.
Yes.
That is one way of doing it. Did everyone do it that way?
I'm seeing some shakes and some nods.
There was another way in this section, and we led with it actually. This format up here.
So we use
R equals 1 minus T times 0, 0, 4 plus T times 2, 3, 0. So how does that work out? Nothing is getting added in the Z component, or only in the Z components for this part. Only in the X and Y components for that part. So I've got 2T, 3T, and then 4 times 1 minus T is 4 minus 4T. A little less work, huh?
compared to Jones, is that always gonna be minus T for the initial point and T for the terminal point?
Yes. For a line segment from 0 to T to 1. If I wanted to go from like 0 to 3, that first one would be 3 minus T.
which means that the t, that's only gonna be when, let's say, when, if it's not a line segment, then you can definitely not use that.
Yeah, this is only for a straight line. It's
Yeah.
not, you don't want to do this for a curve. But for a straight line, this is a great way to go. Notice if we did 0 to 3t, the idea is when we do 0, the right-hand one goes away because t equals 0. And this is 3 times that. And then when t equals 3, 3 minus 3 is 0. The first one goes away, and we have our time component of that one. Generally, we're doing from 0 to t to 1 because it's the more intuitive way. So I wouldn't recommend doing that. It also makes you more work to do. It's easier just to do this vector here and then do 0 to 3 along this if you need to. This is the standard format. So it's r equals 1 minus t times the r naught vector plus t times the r1 vector, where r naught is points to p or p and r1 points to q. Whoa. We're not going to be doing hardly anything with straight lines in here, but it is good work. We do have a lot of lines, but it's generally focusing on tangent lines and stuff like that in this section. Well, this chapter. Let's kick it up a notch. Let's see what else I can come up with there. Let's do a curve. Another curve. Let's sketch RT equals 9 cosine of t plus 4 sine of t plus tk. I guess I should give these, there we go. That's a little bit better. 9 cosine t in the I hat, 4 sine t in the j hat, t in the k hat. And if you decide to do time steps of 1, you are really making this shit hard for yourself. My points look good so far. My table.
That makes sense.
Okay.
Yep.
I think what's the best way to sketch this? I think my first draft is going to be lame, but we'll talk about ways to make it better. So let's just like mark out 9 and 4 like that, not counting any individual spots. I know the 9 is a lot longer than the 4, so I'm going to do it like that. And these will be pi over 2 steps. So the top one's 2 pi, like that. So 900 is right here, right? And then we got 0, 4 up pi over 2 is right there. And then we got -9, 0, which is back here, and then up 2 pi. Well, I'm already making it look shitty. And then 0, -4 is over here, and we're gonna go up 3 pi over 2. And then 9, 0, 2 pi. I don't know, let's see how far this is. Sun camera, yeah. About 1 3/4. Let's go up 1 3/4 here. Put about there. Oop. So it's going like this. I don't know if that looks very good right now. Because this point should be directly above it, and it's kind of hard to see that, right? What kind of shape is this making in like if I just look straight down? If I ignore the Z component, what does this look like?
Close.
Close to a circle, more like an ellipse. So maybe let's sketch an ellipse. Let me grab it. I could do it in green here. Let's just do it real light. I'll add coordinates after I do it. God, that came out bad. Let's try that again. Okay, that's got like an elliptic, or like a cylindrical shape. Now maybe I can do the points a little bit easier. at least shows a little bit better what's going on. It's going around this cylinder. A little hard to sketch though, isn't it? What's going on in each of them though, I want you to remember, is we are tracing out something from the origin to those points. Kind of the way I sketched it here, I didn't make it look very well. Let's see, what else can I throw at you? Any questions? God, I just looked at what that textbook has. I'm going to change what I'm sharing to show you what that looked like, how bad mine is. That's a circle, not a cylinder, but still, it looks way better, right?
Yeah, but they cheated. They didn't draw that.
That's true. That's very true. They didn't draw that.
Yeah, but they program it properly.
Yeah,
It's this
but
part right here
the
that's
reason
really
they
hard to
didn't
draw.
it.
Like here, the arc is super big, but when we're doing that part right here, it's like really tight. And the way I did it doesn't look like that at all. They also don't have the 2 pi point right here, which would be right over here. Oop. Let's see, what else can we grab from this section? Give you guys a challenge on. Oh, I know another topic that's important. I can do it right here. Let's say we have R of t equals 4 minus t squared t cubed and natural log of t. Before we can sketch it, I don't even know how it'll be. I can't even imagine trying to sketch this. We have to know the domain.
T is greater than 1. T is greater than 0.
And the domain is where each of the individual components intersect. So it's the intersection of the domains of the components. So 2 of these have domain restrictions. T cubed doesn't. T cubed could be anything. Our first restriction comes from 4 minus t squared being in the square root. We want to have real numbers, which means the inside needs to be greater than or equal to 0.
You might want to make that 4 minus t squared in your original vector a little more clear, because even to me that looks like a 4t squared. There you go.
So we want the what's under the radical, what is it, radicand? James, you know all the math vocabulary. What is it? The radicand? I bet your dad talks about this shit in sleep. Well, I am rather than well, we can, what is the answer to this? Now, the intuitive thing is to keep the t on the left. And I'll do that up here. I'll keep the t on the left. We'll subtract 4 over. What happens when I multiply through by a negative?
You reverse the interval, right?
We flip the sign, right? T squared is less than 4 means that t is less than 2 and greater than -2.
We're and the equal, right?
Got a question asking whether the t can be greater than or equal to. Oh, that's a mistake.
I missed that, didn't I? So that's one way. It's easy to forget to flip the sign, though. I think the easier way is to add the t squared over. And when you do the square root, it breaks it into 2. It's t is less than or equal to 2, and t is greater than or equal to -2. But when we combine them, it makes that sandwich. What's the domain restriction on natural log of t? Anybody? Do y'all remember the graph of natural log of t?
It can be 0.
It can't be 0. Can it be negative? Can it be positive? What can I do? That is the graph of the natural log of t if I make this t and this y. It's the inverse relationship of e to the t, which goes like that. So this restriction is t is strictly greater than, not greater than or equal to, greater than 0. The y-axis acts as an asymptote on that. So let's match that up with what we got here. T is greater than 0. And this might be easier to look at on a number line real quick. Our first one from the radicand was this range right here. And so this was our radical, square root of 4 minus t squared. And our natural log gives us a hollow point at 0, and it's strictly greater than. So the region of intersection is right here. We can include that point, well, we can't include 0. The only spots we could sketch this on is for t, 0 is less than t, less than or equal to 2. Those are the only values where that vector is real. Let me pull in some algebra 1, 2 shit out of here on you. Make you do some algebra.
Yeah, I mean, it's good to do some algebra every once in a while. You get too comfortable in the calculus field, you forget how to actually use these intervals, work these intervals.
The calculus depends on a lot of algebra in it.
Yeah.
You have done a lot of algebra stuff along the way. algebra and trig. Probably the most in Calc 2, where you got all those trig substitutions and fun shit like that. I wonder how hard that would be to sketch. I know, I want to see where the 0 point is. Maybe do 0, 1, and 2.
Basically.
Well, technically 0 would just be undefined, so you'd have to pick a point really close to 0.
Right, I can put a hollow point there, but it shows me where the vector starts. The vector starts there, but doesn't exist there. So this would be, if I plug in 0, I've got 2,
And he used another one.
0,
That's
and negative infinity. And if I plug in 1, I got √3, 1, and natural log of 1 is 0. And if I plug in 2, I've got 0, 8, and natural log of 2. I probably need some subpoints in there. 1/2, 3/4. 1/2 square root of 1/2, or 1/2 squared is 1/4. 4 minus 1/4 is 3.75. Square root of 3.75. And 3/4 squared is 9/16. So 4 minus 9/16 is 3 7/16, and we're doing the square root there. God, these are getting ugly already, aren't they? That's 1/8. And we cube 1/2. We cube 1 3/4. 3 cubed is 27. 4 cubed is 64. Gets kind of ugly. I don't know how this sketch is gonna look. I don't know that I like it already. But I pulled numbers out of my ass, so let's just do it. 2, 0 is a negative infinity, like there's a hollow point way down here. 1 √3 we'll say is over here. And sorry, √3 is right there, and I guess 1's closer to there, so maybe there. And then I got 0, 8 way over here, natural log of 2. So maybe it's making some curvature thing. Kind of pain in the butt, huh?
Yeah, that worked.
We're getting close to 9. I want you guys to watch 12.2 tonight or this afternoon. 12.2, we are going to start looking at a better option than using time. What could possibly be better than using time? Distance. We're going to start parameterizing by distance, or what you.
I was gonna say, it's like find out next time. on Calc3.
Arc length. Remember arc length? Calc 2 arc length? Yeah, that's
Yeah.
12.2.
Arc length prioritizations, yay!
Right?
Remember all the work.
And when do we see our first like actual like integral?
Why don't we, actually, we're. about
You'll see
to
integrals
start.
coming up.
They're coming up.
Wait, is 12.2?
You gotta miss it. You won't miss it.
Wait, my bad. 12.2 is not the. 12.2
Wait.
is on derivatives and integrals. Sorry. 12.3 is when we do arc length. 12.2 is derivatives and integrals. We'll start doing, you can do integrals tonight.
Class already left, so they're gonna be.
Don't worry, they can, you'll see, you could just say it on the Discord again if you want. Unless you want them just to be confused.
I don't mind if they're confused. That's how I roll.
You have anything else?
That's it.
All right.
Oh, Brandon.
See you
Did your,
guys.
see ya. Brandon, did your timesheet have the times for the, when you're in class like right now?
Yeah, I just went ahead and projected.
I know, I couldn't remember if you had the 8 to 9 hour listed. I wanted to make sure you did.
Oh, no, I did. I projected for all the times up to the 15th because they wanted us to turn the timesheet in by the 12th.
Right.
So they told us to project. I figured the only time I'm gonna be able to get it signed by you is when during test days. You know, like in a decent
Oh, yeah.
manner.
Oh,
Yeah,
yeah,
so
You definitely, anyone that has a timesheet projects. Like I tutor online in the math lab. I have to do projections for the you
yeah,
know, list the time ahead of time. I know it.
don't
I just
worry.
wanted to make sure you had the 8 to 9 hour, not just your SI hours.
Oh no, don't worry. I almost did forget actually when I was putting it in, yeah, a couple days ago. But no, I
Okay.
did double and triple check to make sure I had the times right as well.
Okay, cool. I'll see you tomorrow.
Yeah, I'll see you tomorrow.